Hi guys, I'll try this. So the point PQ is reflected over the line y equals kx, where k is a constant. If p, q are positive integers less than 100, find the greatest possible value of p plus q. Okay, so we don't know... Oh, they're positive integers less than 100. So p and q are... This is the first quadrant. P and q are somewhere, or PQ is somewhere here. It's like there. It's reflected over the line kx. So it actually could go into other quadrants. So the x coordinate is increased. It goes this way, and it goes down. So it's going to be reflected like this, right? Because there's the only way it can go that way is if the line is to the right of it, and the only way it can go down is if the line is below it. Okay. Um. Yeah. If p and q are positive integers less than 100, find the greatest possible value of p plus q. So we need some restrictions about p and q. When we're reflecting something over a line, let me make this line more irregular. It's gonna be like, let's say it's like that. So how do we reflect something over the line? Well, we can create a perpendicular line going through it. So I guess it can be negative, the result. We make a perpendicular line through it, and then we get the same distance here, and we find that point. So it's gonna go... If we find the distance between the x coordinate and the intersection point, then we can just add 2 times that to get this x coordinate down here. This is the same thing. Can we do the same thing with y? Yeah. So can we find the x value of the intersection point? Let's say we have the point 1, 1 in the line 1, 1/2. How do we find the intersection point of the perpendicular of the line to the point? Uh, hmm. Well, we could use point slope form and use the inverse slope. So if we have, we can get, if this line is line L, we can get line L prime. If we say L is y is equal to x, or I'm gonna get the drawing pad. Okay. L is y is equal to k of x. Oh, we don't know. We're trying to find the intersection point. We would have to use... Oh no, I guess we could use this point here. It's equal to k times x. Line L prime is y is equal to 1 over k times x minus p plus q. This is the formula for the line. Can we need to go one distance. Oh no, we need to find where these are equal. So we need to say, find where these intersect. So k times x is equal to, where's my cursor? Is equal to, why is this turning off? 1 over k times x minus p plus q. can multiply by k, we get k squared times x is equal to x minus p plus kq. We can k times x, so I could say k squared times 1, no, it'd be x minus, no, what am I doing? X times k squared minus 1 is equal to kq minus p. Huh. I don't know what this is really telling me. I mean, I have a formula here for the intersection point. The x-coordinate, yeah, I'm trying to find the x-coordinate of the intersection point. So x is equal to kq minus p over k squared minus 1. This is the x-coordinate of the intersection point. So now if I take p plus the distance from this to p is p minus this, p minus k q minus p over k squared minus 1. Why does q matter in finding the x coordinate? Think about it, if you were to raise point, yeah, it would, never mind. P minus, no, it's going to be that thing minus p, because it's further. kq minus p over k squared minus 1 minus p. So now we have, we're adding 2, so this is the x-coordinate of the reflected point. So p plus 2kq minus p over k squared minus 1 minus 2p. So our final answer is 2kq minus p over k squared minus 1 minus p. This is our x-coordinate of this. What do we know this is equal to? We know that this is equal to p plus 10. So we know p plus 10 is equal to 2kq minus p over k squared minus 1 minus 2p, or minus p. So, I think I should think about it more conceptually. If I'm trying to find the maximum value of p plus q, I'm trying to find the largest, the p plus q. So it's going to look like the gradient is like this, with its, like this. We want to make the value be furthest like this. So, what's the greatest possible that is less than 100? So it's, so I can mold k to my liking. K could be anything it wants. So what's the challenge here? I think it's because we have to make it specifically plus 10 minus 8. We know that the point, the original point, has to be in this box here from 0 to 100 on P to 0 to 100 on Q. And then this is like a gradient here with like, uh, what is going on? Like this, but it gets like increasingly darker. We want it to be the most up there it can be. Furthest this way. So why can't it be 100, 100? Then I can just mold the line to how I want to make it like that. I think I can do that. 100, 100. Or 99, 99, sorry. This should be 99. So 198? Question mark? Let's try it. Let's say we have 198, 99, 99. 0.9999 is reflected over that line to get shaped to how we like. To make the point 109, 91. Okay. So now we just need to find the line to make that happen. So we're saying 109, which is the final point, is equal to k times the first point, which is 99 minus 99 over k squared minus 1. Here we see this is k minus 1 times 99. This is k plus 1. This is k minus 1. So those two cancel out. And then we just get 109 is equal to 99 over k plus 1. Then just simplify, multiply by k plus 1 divided by this. K plus 1 is equal to 99 over 109. K is equal to 99 over 109 minus 1. Okay. So I'm seeing an issue here. I got a definitive value for k, given the starting and ending point for x. But for y, that means I get a set value, which might not be what I want. No, this is the, shoot, this is the intersection form. I'm not really sure. I'm not really sure. I think, I don't know. I'm gonna go check. I think it's 198. I'll check. I don't know what I was on. I didn't look at the full answer, but they gave me a great way to do this. We know we can find the slope of this line, which means that we could find the slope of this line, and we also know a point on this line. So, okay. I just got the value in what I saw of the solution was I got the actual answer, which was 170. And there were the two, so this is not right. Then it told me about the slope and the midpoint. So I'm gonna just try to figure it out using that information. So from here to here, from the original point to the reflected point, we know the difference. The difference is 8 over 10, which means that the slope is negative 4/5, is equal to m of this one. M prime, I guess. No, I'll just call it m. So that means that k is going to be equal to 5/4, because k is the perpendicular version of this. So we already know what k is. We already know what k is. So we know, okay, that's why it was so complicated, because we already knew what k was. We didn't have to find all that. And we know the intersection point here is the midpoint of these two. So the midpoint, which is p plus 10 over 2. So PQ is our original point. The midpoint is P plus 5 and Q minus 4. P plus 5, Q minus 4. Now this tells us, this can allow us, I don't know what this can do. Using this we can get an equation for this line here, and we already have the equation for y equals 5/4 k. So, so since this is on the point, on the line, we know that q minus 4 is equal to 5/4 times p plus 5, which is one restriction. So then solving, we just get q minus 4 is equal to 5/4 p plus 25 over 4. Adding 4 on both sides, we get 16 plus, that would be 41. So q minus 5/4 p has to be equal to 41 over 4. I can multiply by 4, so we get 4q minus 5p is equal to 41. Okay. What else does this tell us? So we just need to find the greatest possible value where this is true. Are we sure? Multiple 4 can be 16 minus 5 is 1. So 8 minus 5 is 3, 12 minus 5 is 2, 16 minus 5 is 1, 20 is 0, or I guess mod 5, I mean. 24 is 4, 28 is 3. Okay. So mod 5, the differences go 4, 3, 2, 1, 0. So we're looking for this 1, so it's going to be, what can I do here? 4q, this 41 is 4 times 5 times 2 plus 1. So I could do 4 times q minus 10 minus 5p is equal to 0. So 4 times q minus 10 is equal to 5p. P must be divisible by 4. So P can be like 96, 92. And then Q minus 10 must be divisible by 5. So Q must be divisible by 5. So Q must be 95, 90, 85. So 9. What's the? We have a bound here of 109, 109. 109, so 5/4 P must be less than 109. So divide this by 4, we get 24. Here we get 23. 23 times 5 is too great. 21 times 5 is what we need. So 21 times 5 would be 84. No, that's a lie. So if we have P is equal to 84, that means that Q, but we can't have 109, we need to have 105. 105, is this. So we have 84, and P is equal to 84, Q is equal to 95. I think. I'm not entirely sure. All I know is I didn't get it right. Thank you guys for watching. I'll see you guys tomorrow. Bye.